And just want to say hello and welcome to the 2026 June Algebra 2 live stream. Thank you to everyone who is already here, ready to learn. And yeah, we're going to go through this January 2019 test. The question I get a lot is like, hey, what about the new stuff? And I included in the description a link to my one of my newer videos where I went over the sample items for the new Regents. So that plus this should give you a good idea of like what to expect. But I reading the chat here, I see some people are saying like, "Oh, I'm scared, this or that." But just deep breaths and do your best to learn as much as you can now, and then tomorrow you wake up and just put your best math down on the paper. Okay. Just before we really get rolling here, I encourage you to ask questions in the chat, but please be kind in the chat. Any foul language, hate speech, bullying, anything like that, not tolerated. I just press the mute button and then you don't get to talk in the chat anymore. Okay, so just be cool while you're here. But yeah, hello to everyone here and thanks for being here. So let's get this going. So yeah, once again, we are doing January 2019. I went far back because I figured most teachers didn't do this one. So here, first up, we're doing the multiple choice, and they usually open with a stats or a survey type question of some kind or stats. But here we have two sets of test scores that have the same mean. Okay, so the average is the same for these, and for this, we're told there are two different standard deviations because there's two sets. Set one has a standard deviation of this value here, and then set two with this, and they're telling us the second standard deviation is greater than the first. So which statement best describes the variability of these data sets? The data set 2 has greater variability. And the reason for this, the standard deviation, so just so we're clear on this, I'll get this word here, I'll highlight it. The standard deviation tells you the average. So I'm going to tell you here, this is the average distance from the average. Okay, so the average distance from the average. All right, that's basically what this is telling us, is just like how, erratic the data set is. So data set 2 has greater variability because it has a greater standard deviation. Okay, so that's question 1. And now let's see. Oh, so if anyone wants the newer Regents questions, like I said, I have all the Regents videos up to date for Algebra 2, except for the August test, but I did put a link for the sample questions. Okay. All right. Let's see. Next up, we have f of x is log base 3 of x, and g of x is the image of f after a translation 5 units to the left. So when I hear translation 5 units to the left, so what I'm thinking here is that if we have f of x, then we're going to f of x plus 5. Now, this is like one of those cruel things where it's opposite. People might think, oh, left 5, I'm going to go minus 5, but that's not what's happening here. So 2 is actually going to work out to choice 1. Now, other questions that pop up like, oh, I just want to pass. I just need to get the multiple choice questions correct. I just want to pass. If you're in the I just want to pass category, I'm not going to pretend that this is, not a great trick. But what you do for something like this, you could go math, go to log over here at the bottom. So log base 3. So you just type in the function, and then you go through all the answer choices. Now, this will take a while to type in all of them, but if you type in the first one, let's see here. So we go x plus 5 inside instead. Notice that the graph shifts here to the left 5 units. Okay, so if I follow, let's say this point here, I'm going 1, 2, 3, 4, 5 to the left. Okay, so choice 1 is definitely good. All right. Which question do I think is going to be the 6-pointer? That's a good question. Algebra 2 is the one Regents class that I don't actually teach. So that one's harder for me to predict because I teach geometry and AP calculus. But I don't know, maybe I'll say a log question where you got to do the algebra yourself. So graphing something log based. Or not graphing something log based, something exponential. And then you have to like solve for the time where the exponential reaches a value algebraically, and logs are involved. Okay, so if we look next up here, so this is another one of those, there's a way to do this where you want to reach enlightenment, and there's a way to do this if you're like, hey, I just want to pass the Algebra 2 Regents, and, I'm not trying to hit enlightenment. So they're like, when factoring to get the roots of this, which equation can be used? So for this one, you could honestly just type in the original. So let me just go back to the y equals. We could type in x to the power 3, and then plus 2x squared minus 9x minus 18. And then you could go through all of the Roman numerals. All right. Now, this is going to be kind of tedious, but I would say so is doing this algebraically is going to be somewhat tedious. So let's see, minus 9 and then times x plus 2. And when you do this and you press graph, see how the graphs overlap? So right away, Roman numeral 1 is good. So something like choice 3 is out because it's saying like, hey, 2 and 3 only. But no, Roman numeral 1 works. So then if we look, let's see, x times x squared minus 9. And then plus 2 times x squared minus 9. So if I look at this one, does this match? And it does. So far, 1 and 2 work. So 2 is out. We already said 3 is out. And now the question is, does Roman numeral 3 work? So then I would graph Roman numeral 3, and let's see if it matches. So x minus 2 and x squared minus 9. Okay, so this is if you don't feel like doing the algebra yourself. And this one doesn't match. So you see, like, 3 was the one that didn't work. So it's 1 and 2 only. So this would be choice 1. Okay, so just using calculator magic. I'll get the picture back so we could see. So I just graphed, each of these and this one here. So just so we're like, hey, like, what did you actually do? Like, what was that, math you did in the calculator? So I typed in the functions and then I graphed them to see which ones here overlap. And the only one that doesn't overlap the others was the pink one, which corresponds to Roman numeral 3. Okay, so this one is out. All right, so that's how we do this. If you're like, wait, I want to actually understand this, well, you could factor by grouping. You could say like x squared times x plus 2 minus 9 times x plus 2. And you see how this matches Roman numeral 1? So this is why this works. And then for Roman numeral 2, what they did is they switched these. So like, actually, they didn't switch those two. They switched these two. So they went x to the third minus 9x and then plus 2x squared minus 18. And they factor by grouping again. So you get x squared times x minus 9. And then you get, let's see here. So that was, oh wait, I'm sorry. X, I was just joking. You take out an x, not an x squared. So x times x squared minus 9. And then plus 2 times x squared minus 9. See, factor by grouping. And then that's why this one works. And then the third one doesn't work because if you take out the, which factor is it? The x minus 2. So why is this not? Oh, that would be because here, if we factor this one more step, we would have x plus 2 times x squared minus 9. So you can't just casually change this plus to minus. That's why this one's no good. Okay, so yeah. So let's see. Question 4. So, all right, here we go. When a ball bounces, this one is a tricky question, geometric series. So here, when a ball bounces, the heights of the consecutive bounces form a geometric sequence. The height of the first bounce is 121 centimeters, and the height of the third bounce is 64 centimeters. And then we want to know to the nearest centimeter, what is the height of the fifth bounce? Okay, so for this one, I'll start with an easy one. So like, let's say I had something like 1, 2, 4, 8, 16. If I had a common ratio of 2, see, I just go like 1 times 2, 2 times 2, and then I get 4 times 2, 8 times 2. And I just keep going. This, variability means like how much something changes. Okay. So that's the idea. Oh, the sum questions. Yeah. When I get to them, I'll sprinkle in something about sums. Okay. So here for this one, the key is knowing the formula. When you want to find the nth term, it's equal to the first term times r to the n minus 1. Like this is a good formula to have for finding the terms of a geometric sequence. So here they said the height of the first bound, so A1 is equal to 121. But then A2 would be 121 times R. And then A3 would be 121 times R squared. I would multiply by R again and just do this repeatedly. Okay, so that's how I get from one term to the next. But they told us the height of the third bounce is 64 centimeters. Okay, so if the height of the third bounce is 64 centimeters, then I make 121 R squared equal to 64. Because you see, the third bounce, so this third bounce corresponds to the third term. And then I just have to solve for R. So I go divide by 121. So R squared equals this. And then just take the square root of both sides. And both of those numbers are perfect squares. The square root of 64 is 8 over the square root of 121 is 11. Okay, and then like, hey, what's the height of the fifth bounce? So now what I could do is I could write a formula here. I could say, all right, so see what that was a moment ago? It's the first term. So I could say, all right, 121 times R to the n minus 1. And R we just found is 8 over 11. And now this is to the n minus 1. So if I want to find the fifth term is equal to 121 times 8/11 to the, and if I plug in 5, see I get 5 here and 5 here. 5 minus 1 is 4. So then we just ask the calculator, hey, what's 121 times 8 over 11 to the 4th? So let's see. And let's see, moment of truth. So 121, parentheses, 8 over 11 to the 4th power. And they said to the nearest centimeter, so this would be 34. Okay, so this is going to match up with 34. Cool. All right. So moving on. All right. Next up. Oh, unit circle question. I think someone said unit circle. So unit circle, I'll see. I think there might be one here on the unit circle, but if not, I can make one up on the spot. Okay. So let's see the solutions to this. All right. So for this one, quadratic formula is good to know. So, be good at the quadratic formula. That definitely helps. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And for this question, we have an a value equal to 5. The b value is negative 2. And, be careful here. So it's tempting to say the value c is 13, but you have to make this, remember, it's ax squared plus bx plus c equals 0. Okay, so we should get 5x squared minus 2x. I go minus 9 on both sides. So you see I go minus 9 on both sides. So when I do 13 minus 9, I get 4. So plus 4 is equal to 0. Okay, so just once again, I'll move this over. Over here is we're going minus 9 on the right side and minus 9 on the left. And that brings us here. So the value c is equal to 4. And now we just use the quadratic formula. So x equals, now be careful, it's negative b. Don't say, oh, cool, they already put a minus, how polite. No, you have to, what's it called? You have to make sure that you switch the sign here. Okay, so if b is negative, negative b would be positive. So it would be 2, and then plus or minus square root of negative 2 squared minus 4 times 5 times 4 all over 2 times a. Okay? Cool. So from here, once we plug everything in, now just simplify carefully. So this part here, now we have x equals, and we're going to have 2 plus or minus on the inside here. So inside the radical, we're going to have 4 minus, and then we could do 20 times 4 is 80. So that's 4 minus 80 is negative 76. So I get this, and this is all over 10. And now from here, I'll do this as a little side quest. Square root of negative 76. Remember, square root of negative 1 is I. So that means our answer is going to come out imaginary. So these two answer choices are gone. And then from here, what two numbers multiply to 76 and we want a perfect square? Well, for this, we could say 4 and it looks like 19 works. Yeah, 4 and 19. So if I say square root of 76, I could say square root of 4 square root of 19, and that would be 2 radical 19. But we're going to have the square root of negative 1 pop out as I. So this would be x equals 2 plus or minus I, and then square root of 76, once again, is 2 radical 19. And we're dividing all of this by 10. So then from here, yeah, this question's a lot of writing, but we get x equals, you could do 2 over 10 plus or minus, and they write the I at the end. So I'm going to say 2 radical 19 over 10 and then times I. And then 2 over 10 makes 1/5 plus or minus square root of 19 over 5. So 5 is looking like choice 2. But I'm going to show you a nice magic trick. Okay, so let's say for this, you're like, whoa, that's difficult. I don't want to do all that. I wanted to show quadratic formula with imaginaries just so you could see. But something like this, I go to mode and I switch from real numbers to imaginary, a plus bi. And then what you could do is you could start writing in the answer choices. So I'm going to say alpha y equals enter. And then we got 1/5 plus or minus, but I'll say plus first. And then I could press alpha x or alpha y equals enter. Alpha x is if you have the newer calculators, they could do this. I have square root of 19 over 5. And then I is second, and then this button. And now I'm going to press store. I'm going to store that complex number as alpha math, as the letter A. And now watch this magic trick. So I press 5, and then A is our answer. Like I stored it to the letter A. And then minus 2 times A, and then plus 13. And if this works, we should get just 9. And see, we get 9 plus 0i, which is just 9. So that's how I know choice 2 is good. Okay. For this test, I mean, when to use degrees versus radians. If you're graphing a trig function, make sure you're in radians. Okay. So yeah. Oh, some high schools you're allowed to use Desmos. That's like having like a superpower. Desmos, it's pretty overpowering. Yeah. Yeah, Desmos. Desmos is what they use on the SAT and on AP exams. But it's slowly making its way to the Regents. Like more high schools are like, hey, we want to be able to use Desmos, and they're like granting schools permission. All right. So here, next we have, let's see. Oh yeah, these are classic Regents questions. This shows up a bunch. So even though this test is old, this type of question shows up a lot. So here we have Julia deposits $2,000 into a savings account that earns 4% interest per year. And the exponential function that models this is here, y equals. Okay, so this is just modeling Julia's situation. And this part is important. T is the time in years. So which equation correctly represents the amount of money in her savings account in terms of the monthly growth rate? Okay, so we have to switch this in terms of the monthly growth rate. So one thing I want to point out is think about 1 year is equal to 12 months. Like hopefully that's not ruining anyone's day. So if I multiply both sides by t, like this, that tells us t years is equal to 12 times t months. Like if you want to switch from, like let's say, oh, someone is 5 years old, then you multiply their years of age by 12, and that tells you how many months old they are. Okay, so that's what we're doing is we just do times 12 to see how many months. Okay, so if t is the time in years, then 12t is the time in months. And we're trying to write things in terms of the monthly growth rate, which means we really want to see this 12 times t in the equation. Okay, and then the next thing to know is this. A to the b to the c equals a to the b times c. So when I start with this equation over here, what I'm going to do is I'm going to take 2,000 and leave that alone. But the 1.04 to the t, I'm going to write it out two different ways. I'm going to say 1.04 to the, instead of saying to the t, I'm going to say to the 12. Well, I'm going to actually write it like this. 1 over 12. And then outside, I'm going to write 12t. Okay, because they told us to write this in terms of the monthly growth rate. So I'm using this exponent property that when I raise a power to a power, I just multiply the exponents like this. But why would I do this? Because I really, really, really want to see this in terms of 12 times t. Okay, so I just raise the base to the 1 over 12, but then to balance things, I raise all of that to the 12t. And that would bring us right back to the start. Okay, so now you just go to the calculator and find the new base here. So I'm going 1.04 to the 1/12th power. Press enter, and it's this number here. So, 1.00327737. Okay, so that's going to be our base. So this tells us this is equal to 2,000 times 1.00, and then it was 32737, and then 12t power. Okay, and then you scan the answer choices. This matches up with choice 3. All right, let's see. So, all right, this is a good question. So this is like about the trig graphs a little bit. So let's see here. Oh, and I just got to say thank you to everyone who's here right now. I'll take a second to say hello to the chat. We have almost 300 people on right now, 707 views so far. But just thank you for being a part of this. If you haven't subscribed yet, I would greatly appreciate it if you do. We just passed 49,000 subscribers. So yeah, just thank you for everyone for being a part of this. I'm happy to be on here with all of you, and I'm proud that you're, spending your time well getting ready for this test. So that it takes a lot to be on here. Oh, and thank you for Nikki for the tip. And yeah, I know my students have been saying it. I've officially reached UNC status, so I just have to embrace it. But thank you. I appreciate you all. Okay, so moving on. So let's see. Tides are a periodic rise and fall of ocean water. And then we have, on a typical day at a seaport, to predict the time of the next high tide, the most important value to have would be the. So this is the $1 million phrase here, periodic rise and fall. So functions that do that are sine and cosine. So if I draw this, like here's like just a random, part of a sine or cosine curve. What you could look at here is, and let me just, actually, I'll draw more of that. I'll draw it down here. So it's something like this. All right, not my best artwork. But if I was looking at one full wave, it would go from the maximum to the midline, to the minimum, to the midline, back to the maximum. So this would be one full cycle. Okay, and I could also draw it this way. I could start from the low point and go here like this. Make that a little neater. And this would be another over here. That would be one full cycle. Okay, so that's what we could look for. So here, we want to predict the time of the next high tide. So to predict the time of the next high tide, that would be looking at like, all right, like how long does it take to complete a full cycle? So that's the time. To predict the time of the next high tide, that would be to find the period would be very useful. Like how long does it take the graph to complete a full cycle? So for this one right away, choice 1 is good because the time it takes to complete a full cycle, if I go from the low to the low, like this would tell me how much time it takes to complete one full cycle. So that right away would be our information. The time when the high tide is 20 feet, well, this one here is not helpful because the moment that we reach the high tide doesn't matter. What matters is how long it takes to complete a full cycle, because then we would be able to say when the next one happens. The average depth of water over a 24-hour period, that's not going to help us here. That's just going to tell us the maximum, the minimum, and the midline. So that one's no good. And the difference between the water heights at low and high tide is just going to help us find the midline and the amplitude, that kind of stuff. So this is out. So definitely choice 1. Yeah, this January Regents was definitely a little bit tricky. I think when they make the January Regents, they like overcook it a bit. I don't know why they do that. I mean, I guess it's the quest for more money. But yeah. All right, moving on. So let's see. Question 8. Oh, this is calculator. Unless you have a computer brain, that's going to be hard to see in your head. So here, I'm just going to type that in carefully. So I'll clear out all the other stuff from before. And if we look, 0.5 x to the power 4, and then plus 3.45 x to the third, We have minus 96.65x squared. And then plus 347.7t. Okay, but we're going to use x. And the domain is from 0 to 6. So watch this. Go to window, clear out the x minimum and put 0. X maximum, go to this. And then you could go to the table, second graph. And notice, see how it's going way up to like 344.4? If I press graph, I can't see anything. But if I make my y maximum go up to like, let's say 400, now everything is very obvious, okay? And just from this alone, we could answer the question. So just calculator skills will get you credit. It's not enough to pass the whole test, most likely. If you're like, oh, because I get that question a lot. Will the calculator alone get me to pass? Probably not. Like, I wouldn't put all your faith in it. But if you're good at the calculator, it'll like really help you out. So now the question, over what time interval does the amount of medication in the bloodstream strictly increase? So that just means like the graph only goes up. So let me just fix that. So only goes up. So from 0 to 2 hours, see that? Like here's 0 to 2. The graph is only going up. So question 8 right away is choice 1. 0 to 3 is no good because on our way from 2 to 3, see how the graph starts to drop? Like if this is a roller coaster, like this is when you would start to, like the ride would start to be fun or scary. It would start to drop. 2 to 6 is no good because on our way from here to here, this is just dropping. And 3 to 6, same thing. It's dropping. So choice 1. All right. Oh, Nikki, thank you so much. I appreciate the the support here. Thank you to everyone for being here. I hope this is helping. Okay. So yeah, be very careful when you type these in. There are probability questions coming up. I know probability is like not everyone's favorite. Okay. So imaginary roots, which quadratic has imaginary roots? What I imagine is the graph does not hit the x-axis. So if you have a quadratic like this, or even like this, the graph doesn't hit the x-axis, the roots are imaginary. So when you do hit the x-axis though, what happens is you have a y value of 0. So this answer choice is out because y equals 0 at x equals 3. And then over here, see we get a 0 here and here, and this one's out. Now it's down to these two, but this one, 2 times x plus 3 squared equals 64. If I start to solve this, like I divide both sides by 2, I get x plus 3 squared equals 32. And I take the square root of both sides. I get x plus 3. Be careful, don't say square root of 32. Say plus or minus square root of 32. And then x would equal subtract 3. So even if I use the calculator, you'll see you'll have 2 roots here. Choice 2, we want imaginary. So choice 2 is no good because we want imaginary roots, and this will have 2 real roots. So right away it has to be choice 4. Derek, thank you so much for the support. Confused when you solve if something is independent, what do you do? Yeah, I have one of those questions coming up, like the independent type questions, like the formulas and all that. All right, so here, why is it this one? So where my head goes for this, I think of parent functions. So here's, let's say, x squared. So this is x squared. And then if I did 2 times x squared, would just make this like, more narrow, the graph. It would just increase faster. And then, so this would be 2x squared. And then if I did 2x squared plus 32, you could even graph this in the calculator. It's going to be something like this. See, it doesn't hit the x-axis. Okay, if you even wanted to find the roots here, 2x squared plus 32 equals 0. You could subtract 32, divide by 2, and then x squared equals negative 16. Take the square root of both sides, and you get x equals plus or minus. Square root of negative 1 is I, and then square root of 16 is 4. So I could just say 4i. So these are the imaginary roots. Okay. Alrighty, so next up, we have a random sample of 100 people that would best estimate the proportion of all registered voters in a district who support improvements to the high school football field. And we want to know here, should be drawn from registered voters in the district at A. Okay. Oh, just for one, I'm trying to track the chat. But thank you to everyone saying nice things in the chat. Thank you to Luca for the tip here. I really appreciate your all being so kind. So let's see here. So random sample of 100 people that would best estimate the proportion. All right, so ready, here's an important part. Who support improvements to the high school football field should be drawn from registered voters in the district at A. So the $1 million phrase here, we want a random sample. So random sample means it needs to be at a place where people are likely not going to be biased in one direction. Now, people at a football game probably like football, so of course they would be more likely to support improvements to the football field. Supermarket is good because everyone's got to eat, so this is already looking good. School fundraiser means like, hey, they're all about like, improvements to the school. And a high school band concert, that could go one of two ways. Maybe they play for the football team and they want to have a nice field too. Or maybe they have no connection to the football team and they're like, whatever, that's not really like affecting me. So that's why choice 2. Okay, so you have to like use your imagination a little for questions like this. Okay. Let's see. So next up. So this is where things get a little funky here, the imaginary stuff, right? So here, just know this, I to the 0 equals 1. I to the first equals I to the second equals -1. And I to the third equals -I. Okay, I just multiply both sides by I. This is like the main one though, like the definition. The first two are sort of obvious. And then the third one, I squared equals -1, is the definition to know. Okay, and using this, now we use our algebra skills. Now, if you want, I could show you sort of a magic trick here. Let's say we want to avoid doing this. This only works for multiple choice though, by the way. But let's just say you're like, oh no, I don't like these questions. My algebra is weak. If I write this without the x, like I just write 2 minus I squared, and then minus parentheses, no 2x, just 2 minus I. So this is like emergency, whoops, wrong button. No, this is like an emergency method here if you're like really desperate. So 2x minus I is second decimal, and then 2x, but we're not going to press x, plus 3I. And I press enter. So I get -4 minus 8I. So like that most closely resembles choice 1. So I'm going to say choice 1 is our answer. All right, that's if like you're, once again, really desperate. And it does work here, but I'll show you how to do this like the real way. So I'm going to go on a side quest. So side quest. 2x minus I squared. So this piece, I'll write that over here. And that's going to be 2x minus I times 2x minus I. And then we get 2x times 2x is 4x squared. Then we get minus 2xi. We get another minus 2xi when we multiply these two. And then we get plus I squared. Okay, so this part here in yellow will simplify to 4x squared. And then I get minus 4xi. And then I squared equals -1. So that's how this piece will start out. Okay. Although there is a nicer way to do this. You know what? This was just a joke. So sometimes when you're in the middle of doing a question, you find an easier way. So that was just a joke. This like waste of time. All right, that was my bad. I'm just going to blame it on it being the end of the day. But here, watch out. There's an even faster way. So you could do that. But let's say like 10 minutes later, like then we finally get to the answer. I don't know if you see it now, but there's a much nicer way. Does anyone see it? You could factor out 2x minus I. Okay, and watch. If you take out 2x minus I, you're left with leftovers here, 2x minus I. There's a minus sign. Don't forget the minus sign. And then don't forget the parentheses for this. 2x plus 3i. This is actually much faster. Yeah, sorry for the first way. We'll never get those seconds back in life. So here, 2x minus I times, and now common mistake amongst really strong students is forgetting to distribute that negative. They just go minus 2x, but they forget to say minus 3i. So you get 2x minus I, and then minus 2x minus 3i. And now just simplify carefully. 2x minus 2x just cancels. So now you get 2x minus I from here times minus 1i minus 3i is minus 4i. And then distribute. And minus 4i times 2x is minus 8xi. And then we get plus 4i squared. But I squared is still negative 1. So we get minus 8xi minus 4. Same answer, choice 1. Okay? So algebra, be good at algebra. I mean, you could just be good at some of the calculator tricks, but I don't know. If you're showing up to algebra 2, like, definitely try to learn to use some algebra. I want to point out, because I've been teaching AP calculus for a really long time. I heard someone say this way back, but calculus is honestly like 70% algebra skills, 70 to 80%. Like, so just you being good at algebra, if you're going to go on to higher math, like just, yeah, be good. Yeah, calculator is amazing. You could use whatever, algebraic method you want at home computer. They are the same thing. Yeah. Okay. So let's see. Moving on, I'm trying to follow the... Yeah, calculator really is magic. All right, this question I thought was pretty good. It highlights a lot of cool ideas. And I'll be honest, like full disclosure, I said Algebra 2 is the one class, Regents class, that I've never taught. But I do like doing these videos because it, challenges me to stay current. Teaching calculus, there's a lot of stuff I see all the time. But probability, I basically never do in calculus. So it's good for me to be out of my comfort zone a little. But here, suppose A and B are independent. And for that, we have the probability of A and B. Now, I'm going to abbreviate. This means this is the symbol for the word and. Okay, so that's the nice symbol. Probability of A and B is 0.2. However, because they said things here like A and B are independent, that means the probability of A and B is going to be equal to the probability of A times the probability of B. Okay, so that if they tell you things are independent, then you could assume this is true. If they want you to show A and B are independent, you want to show the product here is equal to the probability of A and B occurring. So here, right away, I start looking at these answer choices. And something like, let's say, 0.4 times 0.3. Well, for that one, I just think, 4 times 3 is 12. But even so, if I did, let's say, choice 1, why is this no good? Because probability of A is 4/10 times the probability of B is 3/10. So here's like probability of A times probability of B. And this would give us 12 over 100, which is 0.12, not 0.2. So that's why this one's out. Now, choice 2 already looks good, but let's see why the others are no good. Because when I multiply these, 8/10 times 25 hundredths is the same as 1/4. And then this is going to be the same thing here if I work this out. I can even say 8 over 40 or just do 8 over 4 is 2. But this is the same thing as 1/5 or 0.2. So right away, like this product here, probability of A times probability of B matches the probability of A and B. Okay, so 2 is it. Now this one, like, why not choice 3? So this is where things get a little tricky. Well, if A and B are independent, that means the probability of A, and this means given B has occurred, equals the probability of A. And this is because, so we could say because A and B are independent. Okay, so once we know this is true, then I could say, all right, well, then if this is not only probability of A given B, this is also the probability of A, then I could use that same approach and just multiply these two and say, all right, 2/10 times 2/10 is equal to, this is going to give us 4 hundredths. Okay, and 4 hundredths is going to give us 0.04. Okay, so that's why this one here is no good. The probabilities are not matching. And then here, when I multiply, once again, I'm not getting 0.2. So that's why this is out. Definitely choice 2. All right. Question 13. So find the A, B, and C value of a cosine curve. Now for this, I'm going to mention the 2026 update. All right, so the new details for this. And the video that I cover this in more detail is in the description. I went over the sample items in a recent video, and that's like the new stuff for the 2026 Regents. But it does have a lot of connection to the old. So A here is the distance between the midline and the maximum or minimum. So here, what I'm looking at here is the midline is happening here. And the midline corresponds to this value here. So I'm going to say C is equal to 3 because there's our midline, cutting right in the middle of the high and the low point. All right, if you're like, wait, where did you get that? Well, the high point is 5 and the low point is 1. And when I take the average of those two, I get 3. So there's my midline. So that means C is equal to 3, which means these answer choices are out. And now we're down to 2. Now, the A value is equal to 2 for the first one and 4 for the second one. So the A value is going to correspond to the distance between the midline and the maximum. Or I could say from the midline to the minimum. But that's going to tell us here, okay, A in this case is equal to 2. Okay, so 13, we could say right away 13 is going to be choice 1. And that's like not even using the B value at all. But let's say I do want to use the B value. So for the B value, we say the period is equal to 2 pi divided by the B value. And here, what I would do is I would solve for the period. And the period is the time it takes. So the time it takes to complete one cycle. Okay, and if we look here, see, this is like my maximum is here. And if I go all the way, here's one full cycle. A full cycle, you could start at the maximum and go maximum, midline, minimum, midline, maximum. And you see I'm going from 0 to pi over 3. So the period is pi over 3. So I could say pi over 3 equals 2 pi over b. And then from here, I could just cross multiply. And I'll have b times pi equals 6 pi, which tells us that our b value is equal to 6. Okay, so that's why b is equal to 6. Now, here's the new detail for 2026. So here's the period, but the frequency, so I'll say the period, if I plug in, is equal to 2 pi over 6, which simplifies to pi over 3. But the frequency, this is the new detail. The frequency is let me make that neat, is 1 over the period, is the reciprocal of period. And when you want to find the reciprocal of something, you just flip it. So it'd be 3 over pi. Okay, so I just want to point that out, that you just flip it. Now, some people might say, wait a minute, like, why isn't it just the coefficient here? And the reason for that is it's how many cycles it completes every 2 pi. If I leave this unsimplified, this would more likely show up here. Actually, let me make this look a little nicer. Before we simplified here, see we had 2 pi over 6. More likely they would show up like this in the answer choice. Let me just fix this. Frequency, they could say 6 cycles every 2 pi. Okay, so if I simplify the period to pi over 3, then I could say frequency is 3 over pi, but that means the graph would complete 6 cycles over a span of 2 pi. And I could even, pull this up here in the calculator just to, highlight that idea. But if I go A is 2, and then it was cosine of 6 times x, get out of here and write plus 3. So I write these in, and now I'm going from 0 to 2 pi. So 2 pi is 2, and then second and this up button here. And I'm going to go negative 10 to 10. But the graph is all in first quadrant, so I'll go here. See how it's 1, 2, 3, 4, 5, 6 cycles over a span of 2 pi. Okay, so it's in a way telling you the rate. In the past, they would just say, oh, the frequency is the b value. But now, just make sure you say it's the reciprocal of period. Anyone taking physics, that's how they define it in physics anyway. This I will skip because this topic, focus and directrix, is out. Okay. If you want to see this, this is just for enlightenment. So this is not on the test. But just so I don't leave anything here unsolved, the concept is when you have a focus and a directrix, the parabola is the set of all points that are equidistant from this point and this line. And when it's the other way around, so let's say my focus is here and my directrix is above, then my vertex would be here and the parabola would open this way. And once again, every one of these points on the parabola, whatever the distance is to this, is equal to the distance to the directrix. So that's how a parabola is defined. So here, I think they give you some info. So let's see. They're telling you here that the directrix is at y equals 7. So this is at y equals 7 over here. And the, let's see, focus is at -3, +3. So this would tell you then, okay, if this is focus directrix like this, then the vertex would be in the middle. Okay, so here from 7 to 3, the middle value would be 5. So that would mean -3, 5 would be the vertex. And then if you remember this formula here. So here, and this is a parabola opening downwards like this. So not my best artwork, but I would say, all right, y equals a, and then I would have x plus 3 squared, and then plus 5. And the only ones that have that are the first choice and the third choice. But since the parabola is opening downward, a would have to be negative. Okay, so when it's opening downward, a is less than 0 when the parabola opens downward. Okay, so that's for those, but once again, I say skip that. Okay, this. You could solve this by hand, but why would you do that to yourself? You ready? This is in the calculator section, so please use the calculator. All right, so here, I'm going to create the left side and I'm going to create the right side. So alpha y equals enter, and I have 2 over 3x plus 1. So we've got this, and then the right side is 1 over x. So I make more fractions. I don't know what I'm pressing. Let's see. Let me try that again. So 1 over x, and then minus. I could press alpha y equals enter, or in some calculators, just alpha x. And then over 3x plus 1. Okay, and I press zoom 6 to fix this. And let's see. It looks like we have to check, do these graphs equal at -1/3, at 1/2? And if we look here, let me stretch this up here. I'll go -20 to +20, just so I could see more of this. Okay, so second trace 5 is where you find point of intersection. And I get nearby, see they're intersecting around here. Enter, enter, enter. And it looks like 1/2 has to be one of our answers. So x equals 1/2 is one of them. And then for the others, what I would do, watch this. You could also do this. Second window. How about this? Second window, go from auto to ask. This is actually probably easier. Forget the last thing I said. And I'll just start writing in the x values. -1/3 shows up as an error for left side and right side. So not -1/3. This is out. And then 1/2 we said worked. See 1/2, they give you matches. And then -2. But I don't even have to check -2 because 1/2 is not next to -2. But let's see, when -2, we don't get matches here. Oh, mode also. I'm going to go to back to real numbers. And I'm not going to go in auto. I'm going to go to decimal. Because then the answers, I think they look nicer. Okay, so 1/2 is the only spot where it works. Okay, so that's how you would do this one. Just type it in the calculator, and then you could set, if you're like, whoa, what just happened with the calculator? Here's a little refresher. You go second window, change the independent from auto to ask, and then you can make a custom table. You could type in fractions, all sorts of cool stuff. All right. If you are doing this by hand, it's a little bit more annoying, but it's doable. It's just why suffer through the multiple choice? All right. Let's see. Savannah got contact lenses, blah, blah, blah. Great. She could wear them 2 hours on the first day, increase. Oh, okay. So for this one, let's just read this carefully. Her doctor says she could wear them 2 hours on the first day. So A1 is equal to 2, and this is in hours. This question's a little wacky, but whatever. and then increase the amount of time by 30 minutes each day. Okay, so for this, if this pattern continues, which formula would not be appropriate? So we want the one that does not work. Which formula would not be appropriate to determine the length of time in either minutes or hours? So you see it could be in minutes or hours. That's kind of annoying, but whatever. And, that she could wear on the nth day. So this one looks like this one here is in minutes. 120 minutes equals 2 hours. And then this means all right, the first day is 120 minutes. So A1 is 120 minutes. And then plus 30 minutes each day after that. So this means the previous day plus 30. So this one works. We want the one that doesn't work. So now let's see. What about this one? Well, if n equals 1, we get A1 equals 90 plus 30, which is 120 minutes. So this is another one in minutes. And then they're adding 30 minutes each day. So this one looks good. So 2 is out. Now it looks like they're shifting to hours. So 2 hours on the first day. And then it's the previous day plus half an hour. But half of an hour equals 30 minutes. So this one also works. So just by process of elimination, it has to be this. But let's see why. So this one looks like hours. And on the first day, n equals 1, we have 2.5 plus 0.5 is equal to 3. Which would mean 3 hours on the first day. So this is no good. Yes, a half hour is being added each day, but no. All right. All right, let's see. So this one, just looking, we have, okay, f of x equals a to the x, where a is greater than 1, and the inverse of the function is. I actually just made a YouTube short on this, and a TikTok. I started posting on TikTok too, just to try to bring more people to YouTube. But let's see. So this one, the properties that are good to know is log base a of a is equal to 1. The reason, so why? Why is that true? Well, the definition of a log, when you have a to the b equals c, you could say log base a of c equals b. This is the fundamental definition of a log. So here, what I think of why that works is because I just say a to the first. It's base, power, and the result of that is a. So this is just a nice identity that we could use. And then the other idea we want is log base a of b to the c power is c times log base a of b. Exponents can go in front. So when they tell you to find the inverse, just remember, in general, we have y equals f of x. The inverse function, we would switch x and y. So I would say x equals a to the y. And then I could do log base a of both sides. I'm going to do log base a of x equals log base a of a to the y. And once we do that to both sides, this power y could go in front. So I get log base a of x equals y times log base a of a. And log base a of a is equal to 1, so this just wipes out. So y, our inverse, is equal to log base a of x, which tells us f inverse of x, I could say, is log base a of x. Choice 3. Okay, so cool. All right. So let me just see. All right, cool. So moving on. So let's see. 18. Kellyanne has 20,000 to invest. She puts half the money into an account that grows. Okay, so 2 different types of exponential growth. So if she has 20 grand to invest, she puts half into an account that grows at an annual rate of 0.9% compounded monthly. So for one, 0.9% is the same thing as 0.9 over 100. And this, just move the decimal 2 spaces to the left, would be 0.009. Okay, so this is the value here. And if you're looking at compounded monthly, well, for that first part here, I'm thinking, okay, compounded monthly is A equals P times 1 plus R over N to the NT power, like this. And for that, I have, let's see, 10,000 because she's taking half the money and putting it in this first account. And then we're doing 1 plus. So we have 1 plus. The rate is 0.009 over. And we're looking here. Compounded monthly is 12 times a year. So this would be n equals 12. So over 12 and then to the power 12t. And then for the next one here, this one is next using an account that grows continuously at an annual rate of 8%. I'm sorry, 0.8%. 0.8% is 0.8 over 100. And this is 0.08. Okay, I'm just joking. It's 0.008. Okay, so with this, then I'm also thinking of this formula. Some people just call it apert. So A equals PE to the RT. So the other part of the sum here, let me just get this. Hopefully I could get this all in one shot. Oh, cool. It worked. So plus 10,000 is the initial investment here. And then E, this rate is 0.008 and then times T. Okay, like this. So now I go scanning here and it looks like it's going to be 2 or 4 because just by the, powers here. So we could cross off 1 and 3 because the exponent here is not matching. But then the detail here is finding 1 plus 0.009 over 12. So let's go ahead and find that. So 1 plus 0.009 over 12 is the base here is 1.00075. Okay, so that's why choice 4, because this works out to 1.000 and then 75. All right. Cool. Alrighty. Now, question 19 is good. These multiplicity questions. So when you have something like here, just to help you understand, so we're clear on this. If I have a simple graph, so let's say I look at a graph of x minus 1, and I'll presume 6. So x minus 1, actually I'm going to write it like this, x minus 1 to the first power, even though that's still x minus 1. See how here we have the graph goes through the x-axis. If I change this to a 2, x minus 1 squared, that's an even power. Now the graph is tangent to the x-axis. It touches the x-axis at one place at x equals 1. If I change that power to a 3, then see how it goes through the x-axis? And if I go to 4, an even power, it's back to being tangent again. Okay, so that's what's going on. So let's see. People have a question about 16. So for this, I'll go back to 16 as soon as I finish talking about this and see I'll see what's going on. It's hard to follow the chat, mute the trolls, and do the math at the same time. It's really, I have 2 monitors, which helps, but maybe I need a third monitor, one for the chat, one for the trolls, one for I don't know. So here, let's see. Where was I? Oh yeah, so choice 4, yay. But 19. So if this is a factor, x squared plus 2x plus 1. You ready? If this is a factor, this breaks down what 2 numbers have a sum of 2 and a product of 1. Hopefully this doesn't ruin your day. X plus 1, x plus 1. All right, 1 plus 1, first day of school is 2. 1 times 1 is 1. This makes x plus 1 squared. So if this is a factor, that means the graph, we have a root. So I look at this and I say, all right, factor of x plus 1 squared is equal to 0 when x is negative 1. So that means the graph is going to hit 0 at x equals negative 1, but it's going to be one of those tangent situations because this is even. Okay, so we want a graph that's tangent at x equals negative 1, which right away looks like choice 1. This one's no good because you see at x equals negative 1, we have a root, but it goes through, not tangent. Same thing here. This is no good. Same thing here. This is no good. It goes through, but this one is the only one that's tangent. Okay, so this one. All right, question 16. What's wrong with 16? Why did that? Oh, so what was the question before? Um, question 16 is calling. What's wrong with question not getting 16? Oh, all right. I mean, I could explain it in a different way. Let's see. So there's two types of sequences. There's, recursive sequences. Just think like, well, hopefully you never have a recurring nightmare. But a recurring nightmare is like when it's just like the same nightmare over and over and it's just built on the previous thing. So what you look out for is like a sub n equals like a sub n minus 1, like plus whatever. So this represents like the previous term. Okay, so this is the previous term. So right away I'm like, all right, this is like the previous thing plus 30 minutes. So like if I explain why like choice 1 is no good. So let me just explain choice 1 in a little bit more detail here. Hopefully this helps. So if A1 is equal to 120, let's say I plug in, all right, n equals 2. If I plug into this formula here, see how I get A sub 2 equals A sub, I'll pretend I don't know 2 minus 1 is 1, and then plus 30. And this becomes A sub 2 equals A sub 1 plus 30. But you see how this is the, like here's A2. This is like the new one, the new term. And this is the previous. So it's like, oh, it's always like the new one is always the previous one plus 30. Like that's why this was out, because we're starting at 120 minutes. And then it's like, all right, the previous time plus 30 minutes. And they're saying like Savannah's increasing the length of time she wears the contacts 30 minutes each day. So when you see the A sub n minus 1, think of that as like before A sub n. It's the previous one. If it was like A sub n minus 2, that's like, oh, 2 terms ago. All right, so like that's how I thought about 16. I hope that helps a bit. But this one here, if you just investigated a little bit more, like why choice 4 is the answer, like you could see here, if you plugged in 1, so n equals 1 gives you A1 is 2.5 plus 0.5 times 1, which tells you A1 is equal to 3. And right away, they're like, hey, the first day is 2 hours, not 3 hours. So like that alone. Cool. Yeah, for the people just joining, for one, welcome. If you haven't subscribed, consider subscribing. It does help me grow the channel. But I want to point out the new stuff, the sample items I put in the description. Okay? But yeah, just pointing that out. All right, this question towards the end. So just know the last few questions, like 20 to 24, like a few are a few might be cruel. Okay, might be cruel. So just know like they might throw some like evil stuff your way. Like something like this, students are probably like, ooh, like regression, but no. This is not time. This is the number of half-lives. So sodium iodide 131 is used to treat certain medical conditions. And it has a half-life of 1.8 hours. The data table shows the amount of sodium iodide rounded to the nearest thousandth as the dose fades over time. And here, what is the approximate amount of sodium iodide that will remain after 18 hours? So this one was like kind of an unconventional question. I don't know. Sometimes they throw these in just to be funny. But they said like, hey, one half-life is going to happen every like 1.8 hours. So now watch this. Like 18 hours. See how it's like 1.8? I just go times 10. But then times 10. So here, this would be 10 half-lives would be occurring in 18 hours. So you see what's going on here? It's like the amount of sodium iodide is here at 139. And then like if you just follow this in the calculator, you'll see what's going on. So let's see. If we look at this, so we've got 139. And then a half-life just means like times a half. Or I can even say divide by 2. How about that? 139 divide by 2. So you get this number, and then divide by 2. You get this one, and so on. But if you want to kind of write a formula here, we could say, all right, 139, we're multiplying by a half repeatedly. So for this, I'll say n minus 1. How about that? So like y equals like the amount. I'll call this y. And let me actually, I'll put, yeah, n is the number of times. How about that? Or I could say, no, I'll use x so that it looks like a normal equation here. So I'm like a little all over the place. So how about x minus 1? So this would be x. And you can see here that if I plugged in x equals 1, I would get 1 minus 1 is 0. 1 half to the 0 power is 1, and I would get 139. So if I want to know what's going on when x is equal to 10, so because 10 half-lives is going to be like 18 hours, then I get 139. So I say y equals 139 times a half to the 10 minus 1 is 9. So I could just keep dividing by 2 a few more times, but I would lose track because I'm getting old. And I would rather just type it in one shot. So 139 times 1 half, I'll just say 0.5 to the power 9. And you get 0.271. Okay, so let's hope. 0.271. So this is roughly 0.271 and this choice. Okay, cool. So next up, which expressions are equivalent to this where x is not equal to 0? This is another one of those calculator all the way questions. So just type this in the calculator. You get choice 4, but I'll show it without a calculator because I already showed how to type in the calculator. So this, I could start by, let's see, how do they, oh, I see one. All right, so here they factor out an x on top. And you get x minus 4 over 2x. And then you could just cross off the x's. And this is x minus 4 over 2. So like definitely this one. Okay, so that one works. Now, it's just like a game of just kind of trying to make this. So now this one, I could also go like this and say x squared over 2x. So I divide this by 2x and I divide 4x by 2x. And then x squared over 2x is the same thing as x over 2 minus x over x cancels and 4 over 2 is 2. So you see how this matches this? So 1 and 2 work. And now why this one? Now you might have a hard time seeing how this connects. But what you are allowed to do here is you could here use the calculator even, but let me see, how do they make this happen? X squared. Oh, I think I see it. Okay, all right, they did this. So take the original. So take the original x squared minus 4x over 2x. And they went x squared minus 1x minus 3x over 2x. See that? They just broke this into pieces. Why? Just to be difficult. But you could just use a calculator for this. But, I mean, it is an algebra, Regents. I should show you some algebra, too. Okay. So here, now I could break this up. I could say, all right, I'm going to do x squared. So next I'm going to do x squared minus x over 2x. And then minus 3x over 2x. And then this becomes x times x minus 1 over 2x minus x over x cancels and we get 3 over 2. And notice how here x over x cancels and we have x minus 1 over 2 minus 3 over 2. So they all work. But calculator. All right. All right, let's see. So, all right, I see here. So this one, they give us the function f of x explicitly, and p of x, we get a graph. And they want us to find, so here, the difference between the values of the maximum and minimum. So here, the maximum value of p of x, so this part is like fairly easy to find. The maximum value of p of x is just 5. See, 1, 2, 3, 4, 5. So that's here. But we have to find the minimum, so the minimum of f. So for this, there's a few different ways we could do this. Just think about it. The minimum value of a parabola occurs at the axis of symmetry. And that's when x is equal to negative b over 2a. So you could use that formula if you want, or you have a calculator, you could just trace it, because I think it works out to a not nice number in this case. So let's see, calculator. We go to the y equals 4x squared plus 6 times x minus 3. I press graph, and I have to find the minimum. So you ready? I can press second, trace, minimum is number 3. and I go before. So go to the left of the minimum, you press enter once. Go to the right, you press enter a second time, and then you press enter a third time. And you get when x is negative 0.75, y is negative 5.25. So remember that value. Y is negative 5.25. So here, negative 5.25. But the question is, what is the difference between them? Okay, the difference between the maximum and minimum. Well, here we have a maximum of 5, and the minimum is this. So if I do 5 minus the minimum, that gives us 10.25, choice 4. Okay. Geometry will be the day before the geometry Regents. Okay, so I will do another live stream. Okay. All right, moving on. So let's see here. Oh, this is one of those normal CDF questions. Oh, my bad. Am I going at hyperspeed? I'm sorry if... I think also it's like late and the test is early. So like I would hope some people would get sleep. I don't want to encourage people to stay up too late. Yeah. All right. So let's see. Moving on. So question 23. We have the scores on a mathematics college entry exam are normally distributed with a mean of 68 and standard deviation 7.2. Okay, so this one, it helps to be able to draw these out. I think on the new one here, you do have to be able to draw this like to some extent, or like no more than just the formulas, like the concepts help. So 0 standard deviations is like right at the average. So the mean is 68. And they tell us the standard deviation here is 7.2, which means I do 68 plus 7.2, and that would be 75.2. Okay, so 75.2 would be the next value here. So this is just to give you like a rough idea of what actually is going on. If I subtracted, so let's say I like also subtract, maybe I'll do that in this color, then I would get 60.8. Okay, so 60.8 would be over here, and this would be 1 standard deviation backwards. Okay, and then if I went 2 standard deviations, I would add 7.2 one more time. Okay, and that tells you like the percent of people that are scoring there. But here, let's read this. Students scoring higher than 1 standard deviation. So students scoring higher than 1 standard deviation above the mean will not be enrolled in the math tutoring program. Okay, so more than 1 is here. And they're not going to be, all right? So they will not be enrolled in the math tutoring program. And we want to know, so how many of the incoming students can be expected to be enrolled in the tutoring program? Okay, so for this one, there's a few ways we could do this, but we're actually looking for like how many students are in this space over here. So this is like, the wording is tricky. That's what I mean. Like the questions at the end are kind of cruel that you want to see like, all right, like what am I actually counting here? But now that we have that, so let's see, we will go to this and say, let me just zoom out a little bit so we could see. So second vars brings you to normal CDF, option 2. And let me get out of the graph actually. So second vars, normal CDF. Now for the lower bound here, I want to say like, all right, let's pretend they got a 0 on the test. That's the lowest. And then for the upper bound, that would be up to 75.2. Okay, so we could go up to 75.2. And now we have to say here the average. The average is 68. And the standard deviation is 7.2. And then I just press enter the whole way. And this is the percent here, but this is the percent, oh, I'm sorry, the proportion. And I multiply that by 750 to see how many kids here can be expected to be enrolled. And it's going to be 631. Okay, so just to summarize what just happened here, because that might be like, whoa, you know, what are you doing? All right, so this. So if we look, we have over here, we had to do a little bit by hand. You take the average and add 1 standard deviation to see like what would be the score 1 standard deviation above the average. And if they're seeing like how many people are going into the tutoring program, they said everyone one standard deviation and above is not. So it's everyone from here backwards. So from like a score of 0 to a score of 75.2. And then you put the other information in, multiply that proportion by the total, and you get choice 1. Okay. And now a nice question to end with. Okay. So from here, let's just see. We have, all right, let me go to the calculator. So how many solutions exist for this? So this is really just like, it's actually a nice question to end with because you're not going to want to solve this by hand. So to make a fraction, you can press alpha x or alpha y equals enter. And you have 1 over 1 minus x squared. And now on the right side, negative math, go to the right, absolute value 3x minus 2. And then plus 5. Okay, zoom 6. So here we have 1, 2, 3, 4 intersection points here. See, 1, 2, 3, 4. Okay, so that's going to be 4 answer choices. And yeah, that's just what we're going to get here. So choice 4. Okay, so good. All right, so let me just see. All right, and I'm just all right, reading the chat here. Let me see. I got to get caught up. Alrighty, so moving back on to this here. No specific request. Why is it? Oh no, I hope the chat didn't freeze on me here because I'm having a hard time scrolling. All right, so hopefully I'll just keep continuing here. All right, so this one, question 25. Now we move on to the free response. Now, some of the free response questions, I'm just going to show like how they made the graphs because like some of them are going to be annoying to do. It's going to take way too long. And I do want people to, eventually, move on to like unwinding and getting, go to sleep or something. But I'll get as much of the message across as I can. So here, justify why this is equivalent to this using properties of rational exponents. So here, just know a to the b over c, we say power over root. And this is equal to the c root of a to the b power. All right, I could also put the power outside. Either one is fine. So that's one we're going to use. And then I'll write other properties as we need them. So this one here at the start. So this, I could say cube root of x squared y to the 5 over 4th root of x to the 3rd y to the 4th. This is equal to cube root. For one, I could split up a radical too. I could say, all right, cube root of x squared times cube root of y to the 5th over 4th root of x to the 3rd times 4th root of y to the 4th. And now this is equal to, now we use that power over root stuff. So this is x to the power 2 over the root 3 times y to the power 5 over the root 3. And then we divide by x to the power 3 over the root 4. Okay, and then we get y to the 4 over 4. Okay? Let me just see. All right, let me just see. Anything else? All right. No, just trying to follow too in the chat. But so now the next property to know. A to the B over A to the C is A to the B minus C. So here we're going to have x to the power 2/3 minus 3/4. So now I could subtract these powers here when I divide. And then I have y to the 4 over 4 is equal to 1. So that's 5/3 minus 1. And now this is equal to x to the, we don't have to do the fraction part ourselves. like y is 2/3 minus 3/4 equal to negative 12, negative 1 over 12. And for that, I mean, if I did, I would go 4 over 4 here and times 3 over 3 here. And this would equal 8 over 12 minus 9 over 12. And 8 over 12 minus 9 over 12 is negative 1 over 12. And this would be y to the 5/3 minus 1. I would say minus 3 over 3. And that would make 2/3. Okay, so that's where the 2/3 is coming from. So justify y, just showing the progression of the math. All right, if you're like, oh, I don't like fractions, this is too much, 2/3 minus 3/4. And then math, enter, enter. And you get your answer. All right? Cool. All right, let's see. Alrighty, so moving on. So this, sketching a function. So for this one, they're telling us we have the zeros of a quartic polynomial function. So that's degree 4. So that means exactly 4 roots then. If they give us 4 roots, then it's going to have 4 roots. So let's see. So 1, 2, make it neater. So 1, 2, 3, 4. 1, 2, 3, 4 this way. So we have a root at plus or minus 2. So we'll say this is 2. And this is minus 2. And then we have roots at plus or minus 4. So 4 and minus 4. And then for this, we just have to sketch this. So I could just go draw this nice and connected and smooth. So actually, it's not as easy on the writing pad. So let me just see here. So we got, I'll just press Control Z. It's easier, I would say, in person to draw this. So here, sorry, 1 hour later, I'll have this done. Okay, so here, here, and then like this. Okay, so that's fine, just a sketch. Nice, connected, and smooth. Okay, no sharp turns or anything crazy like that. Okay. So moving on here. All right, so Erin and Krista were working on cubing binomials for homework. And Erin believes she would save time with this shortcut. And she wrote down the rule. Does this shortcut always work? No, it doesn't. All right, and here's why. A plus b to the third is equal to a plus b times itself 3 times. Okay, so you have a lot of multiplying to do. So this then becomes, in the next line here, you could do a times a is a squared, plus a times b is ab, plus b times a is still ab, and then plus b squared, times one more a plus b. So then this becomes a squared plus 2ab plus b squared times a plus b. So then I have to multiply this one more time. So you see I do a times a squared. So a squared times, a squared times a is a to the third power. And then times a in the middle gives me plus 2a squared b. Then I get plus ab squared. And then I distribute the b term. So I get b times a squared is a squared b, plus b times 2ab is 2ab squared, and then plus b times b squared is b to the third. I'm going to show you a nice magical shortcut after this. So then we get a to the third plus, this is 2a squared b plus 1a squared b is 3a squared b. Plus, and then here we have ab squared and 2ab squares, which is 3ab squares, and then plus b to the third. So we actually have to say here, does Erin's shortcut always work? So I would say no. Erin's shortcut does not always work. Okay, you can even just say no and just leave it at that because they said justify, and that's the work. So no, Erin's shortcut does not always work. All right? Cool. All right, I would even just say, you know what, how about this? Just say like no. That's like simpler. Just no. I'd probably write that at the beginning too, like leave a space. Does Erin's shortcut always work? Like no. And then justify. All right. So here's the cool shortcut. Pascal's triangle. If you don't know this, like start with a triangle like this, 1, 1, 1. You put another 1, but then 1 plus 1 is 2. And you put another 1. And then 1 plus 2 is 3. 2 plus 1 is 3. And notice the coefficients here. It's 1a to the third and 1b to the third. You see how it's 1, 3, 3, 1? That's a fast way to get the coefficients. If I wanted to see like a plus b squared, that's going to be this row. And I would have like a squared, ab, and a b squared term. And the coefficients would be 1, 2, and 1. So it's a nice little trick you could use to just expand binomials quickly, especially when their coefficients are both 1, like 1a and 1b. But just pointing that out. Cool. All right. Now, let's see. Oh, probability. So people were asking about probability. So here's a probability question. So we're getting there, though. We're almost at the end here. We've been on for an hour and 25 minutes. So, alrighty. So we have... Oh, so at Lamar, could you be more specific? Like, what about trig do you want to... Graphing tangent, I heard. Okay, so there's graphing tangent. All right. But I'll save something like that for the end. I'll mention some trig stuff. That hopefully helps. Okay, so here, probability that a resident of a housing community opposes spending money for improvements on plumbing. So I'll say A is opposes spending on plumbing. Okay. Oh, thank you for the tip in the chat. I appreciate it. So opposes spending on plumbing. And then B is the other one. Okay, so B, I'll make the other scenario here that a resident favors spending money on improving walkways. So supports or favors spending on walkways. Okay. So from here, what we could do is they tell us the probability that a resident opposes spending money on improving plumbing is 0.8. So probability of A, my bad, I should have done this in purple. Probability of A is 0.8. And then they tell us over here the probability that, let's see, the probability that a resident favors spending money on improving walkways, given that the resident opposes. So here's the conditional probability. Given that they oppose spending money on plumbing issues is 0.85. So that they're telling us here the probability that, read that, sometimes you have to reread it more than once. The probability that they favor spending on walkways. So that's probability of B, but then given that A occurs, okay? Given that the resident opposes spending money on plumbing. So they're telling us the probability of B given A is 0.85. Okay, so if we look from here, they want us to solve for the probability that a randomly selected resident opposes spending on plumbing and favors spending on walkways. So they're asking us to solve for the probability of A and B. This is what we're looking for. So this, you can memorize formulas. I have a nice way, I think, of helping you remember the formula. I think of the concepts. Okay, so here's the concept. If you have A and you have B, this part here, the probability of A and B would be over here. But they're telling you over here in green, the probability that B occurs given A has already occurred. So if we're restricted to just A, like this is the condition. So this is the condition here that we're restricted to. That tells us we could eliminate everything else. Okay, everything that's not A, because A is happening. So then how do I combine these three? Well, the probability of B occurring given A occurs is equal to the probability of A and B, because the only way B is going to happen is in this overlap because we crossed everything else out, divided by the probability of A. All right, so that's the formula. You could just memorize that if you want, but I need to understand it for it to actually, for this to work. Oh, Ed Ghost, thank you so much. I appreciate your generosity here. Thank you. But I just happy knowing that this helps here. So you could just like stay tuned. Let me see. Have I ever played? I'll maybe I'll give that game a try over the summer. I recently got back into Nintendo Switch. I haven't played a console or games in a bit. I played like a lot of old school games, but I am a fan of video games. I think they're pretty fun. Depending on the game, there are some classics out there. So let's see. Probability of B given A is 0.85, and this is equal to the mystery value here, the probability of A and B, divided by probability of A. And now we just cross multiply. And this tells us here this is equal to 0.68. Okay, just multiply 0.85 times 0.8, and you get this. And that's our answer. Is it a, let me see. Oh, okay. I could, yeah, I'd have to look into it. So, all right. Question 29. Yeah, if people are fizzling out, thank you for stopping by. But what's it called? Just get some rest, whatever. Stay as long as you want to stay. If you feel like you learned enough, then just good luck tomorrow for anyone. I am not live every day, but at Green Flame I do have a lot of Regents videos, and just general content videos, like from kindergarten all the way up to calculus. Okay, so whatever level of math. Probability of B given A occurs. Okay. So let's see. Rowan is training to run in a race. He runs 15 miles in the first week, and each week following, he runs 3% more than the week before. Using a geometric series formula, find the total number of miles Rowan runs over the first 10 weeks of training. Okay, so here, if we want to write this term by term, this is geometric series. And the formula S sub n is equal to the first term times 1 minus r to the n over 1 minus r. Okay, so that's the formula that you want to use for this question. And it's in the back of the Regents. So here, the other one I think of is Algebra 1, back when life was easy. Okay, in Algebra 1, you learn this formula. A equals P times 1 plus R to the T power. So here, 3% would be like saying, all right, not this R, though. That's why this is confusing. Like, this R is like, maybe I'll change that formula. I'll call this like W instead. But then like this whole thing here is R. So if I said like, all right, like W equals 3%, 3 over 100, which is 0.03. So the R value here, the multiplier, is 1 plus 0.03. So R would be 1.03. And then if you follow this, so Rowan is training to run a race. So let's see, it would be for the first one here, A1 would equal 15. And then A2 would be 15 times 1.03. But then we multiply by 1.03 one more time, and we get this. And then by the time we get to 10 weeks, so the first 10 weeks, so A sub 10 would be 15 times 1.03, but don't say to the 10th, to the power 9. Okay, if you notice the relationship here, like whatever the subscript is, the power is 1 less. So you see like 3, and then it's a 2. So then when it's 10, it's going to go to 9 like this. But for the geometric series, we're adding this. Okay, so we want to find the total number. Okay, we're finding the total number. So for the total, so the total is going to be 15 plus 15 times 1.03 plus all the way down to the 10th one, 15 times 1.03 to the 9th power. Okay, now you could do this in the calculator. It takes time, but you could do this. Or what you could do is you can use the formula here. All right, the formula is much nicer. So here, what I'm thinking is like, all right, n is equal to 10. and r is 1.03. So then we go, all right, sum of the first 10 terms is a1 is my first term, 15, times 1 minus 1.03 to the power n equals 10, divided by 1 minus r is 1.03. Okay, and we're rounding to the nearest thousandth. So calculator. All right, so alpha y equals enter, or just alpha x. And we get 15 times 1 minus 1.03 to the power 10. And then 1 minus 1.03. And we get 171.958. Okay, so 171.958. So 171.958. All right. Cool. So that's question 29. Alrighty. Question 30. We are getting there. Let's see. So this one, the average monthly high temperature in Buffalo in degrees Fahrenheit can be modeled by B of T, where T is the monthly, T is the month number, and state to the nearest tenth the average monthly rate of temperature change between August and November. Okay, so for this one, like January is 1, so hopefully you know your calendar stuff. So August is equal to 8, and November is the 11th month. Okay, so that's what we're using here. So when we set this up, we're plugging in, we're finding the average rate of change. So I also think of this formula here, f of b minus f of a over b minus a. It's like finding the slope. So we're doing b of 11 minus b of 8 over 11 minus 8. And if I write the units here, we could look here. B of t is the degrees Fahrenheit. So it's like degrees Fahrenheit. And this is like in months here. So like per, I'll say per month. So degrees Fahrenheit per month. We're going to find the rate. So now calculator. Okay, so calculator. And let's see. Oh, Ghost, thank you. Thank you, Ghost. You really super generous, but I'm perfectly okay if you just, spend the rest of your time like just focusing on the review. But I do appreciate you, but yeah, you learning is like more enough of a gift. So let's see. Mode, make sure you're in radians. All right, so here 25.29 sine of 0.4895 t, and then minus, just don't make a typo here, that would be real that'd be a real tragedy, and then plus 55.2877. Okay, so I'm going to show you a nice magic trick. I have this saved here. I'm like, oh no, I can't see anything. But when I go back to the main screen, I could do, well, I guess I could also go to the table here and just type in. Like, remember, we still have this in second window. We turned auto to ask, so we can make custom values. So I could type in like 8 and 11. And then I could just subtract these two and divide by 3. All right, so that works. I mean, we could do that. So if you'd rather just do that, here, I'll even copy these values down. We'll show that we're going to get the same, answer that we would have got doing this a different way. So here, let me just clean this up a bit. Okay, so this, I could just go and find here. So 48.598 minus 78.866 over 3, and it's degrees Fahrenheit per month. And then I'll just get rid of this one here. So if I get rid of this, and then I just type in, then I'll show you another way to do this that I think is even cooler. So we've got 48.598. I don't know what I just pressed. Here, alpha x to make a fraction. 48 0.598 minus 78.866 divided by 3. You get negative 10.1, which is our answer. But watch this. I could also go b of 11 is alpha trace y1 is where we saved b of t. And I could just say parentheses 11. And that writes the function value at 11. Minus the function value at 8. So alpha trace y1 of 8 divided by 3. See, and I get negative 10.1. Same answer. Because we're going to the nearest tenth. So this is negative 10.1 degrees Fahrenheit per month. Okay, and explain what this means in the given context. So then you just reread the question again. It's the average monthly temperature in Buffalo in degrees Fahrenheit can be modeled by B of T. So this just tells us the average. So the average monthly temperature in Buffalo. So since the average rate was negative, that means decreasing. So the average monthly temperature in Buffalo is decreasing at a rate of 10.1 degrees Fahrenheit per month from August to November. Okay, which makes sense because we're going from the summer months towards the winter months. So the average monthly temperature in Buffalo is decreasing at a rate of 10.1 degrees Fahrenheit per month from August to November. Okay, so that's what's going on. Unit circle, everybody's favorite. Okay, so the unit circle. So you don't have to draw this out, but I think it helps you understand what's happening. So here they said over t and then up 4/7. So the unit circle goes one out in each direction from 0, 0. Let me actually just maybe fix this a bit. That's a little bit better. And they're telling us here we're in the second quadrant. So that means that we're going to be, if I'm going up 4/7, that's a little more than a half. So that's like probably somewhere here. So this is the point we're looking for. So t comma 4/7. And I made this into a YouTube short, I think, recently. So the equation for the unit circle tells us we're on x squared plus y squared equals 1. So then all I got to do is just plug in t. I get t squared plus 4/7 squared equals 1. And I'm solving for t. So t squared, don't say equals, just kidding, plus 4 squared is 16 over 7 squared is 49. And 1 I'm going to call 49 over 49. Because when I solve for t, so let me just move these up a little bit. So this I'll move up. And then these, whoops, I'll move these up too. So I have space to do the math. So minus 16 over 49, minus 16 over 49. And then that tells us, I'll write the result over here, that t squared equals, and when you subtract, you get in the numerator, 49 minus 16 is 33. So I get 33 over 49. Okay, and then from here, I take the square root of both sides, but be so careful here. Okay, remember, the square root of t squared is not t, it's plus or minus t. And since t is the x value and we're in the second quadrant, t is actually going to be negative because t is, oh, I'm sorry, I'll say this. Because point M is in quadrant 2. So t is less than 0. Okay, so that's very big here. And then I just have to say, all right, square root of 33 is square root of 33 over square root of 49 is 7. But they didn't say simplest, like, rational denominator, rationalize the denominator or nothing, but that's evil, okay? Evil, evil. So, yeah. All right. Let's see. Let me see. All right, next one here, we're just graphing. Let me just see. All right, so next up, we're graphing this. So calculator. So y equals math, go to log base 2 of x minus 3. And there's a plus 1 on the outside. Okay, so we do this. Now, what's not nice is like the calculator cuts off the vertical asymptote, but a little trick. The vertical asymptote occurs when the inside is 0, so at x equals 3. So that's a little trick you could use. Second window, I'm going to put the table back to auto and see like where this stuff, starts showing up for us. So now let's go ahead and do this. But just to point out, let me get the actual graph here too. All right, just so we have an idea of what this is going to look like. So these two together really help. So 4, 1 would be over here. So this is 4, 1. Then 5, 2. Let me zoom in a little more. Okay, 5, 2. 7, 3. So over 7, up 1, 2, 3. Make that a little near. And then, so this is 7, 8, 9, 10, 11. And at 11, we're going up 1, 2, 3, 4. Okay, so, I mean, if you want to number these, you can. You could, write one at a time. But they scaled it for us. But remember, a little mental math is for the vertical asymptote occurs when the inside x minus 3 is equal to 0. And that's when x is equal to 3. So I just focus on the inside of the log. And what that means is that at x equals 3, that's going to be our vertical asymptote for our log function. So when I draw this curve connecting them, I just have to draw this. And I like to put the dotted line there to show like, hey, this is a vertical asymptote. And then that's good. Once you have your 4 points like this and that, like that, that'll get you the credit. And that's our last 2-point question. This I'm going to skip if you want to see, because they no longer do 3x3 systems. This is like not on the 2026. Okay, so I'm going to skip that. If you want something, though, just to have, I could pull up the model responses. I did this one in my notes, though, just for enlightenment. But for the sake of, getting through the rest of the live stream here, I think I'm going to omit this one just to save time. But here, I'll screenshot, the model response full credit solution if you just want to see the idea. But the idea is you want the terms here to have matching opposites, and then that way you could eliminate terms here. So there's a lot of different ways you could go about this, but see how they're getting, terms to cancel out like this, and then you get an equation involving just B and C. What I'll do is I'll put this in the chat, the model response link. So this one here, let me just throw this in the chat. And if people want to check out the model responses, you could look at this one. But like I said, that one's being omitted. So I don't want to explain something that you don't have to know for tomorrow, because it's just like kind of not best use of our time. Okay. So now here, given a of x equals this and b of x is this, we have to determine the quotient a of x over b of x in this form here, where r of x is the remainder. So polynomial division here, I'll go with. Because the sample response, they gave ones where they don't want you to use synthetic. They want you to use polynomial. So just in case you get one that's like absolutely got to be polynomial, I'll show polynomial division. So we have x to the 4th plus 2x to the 3rd plus 4x minus 10. And we're dividing by x plus 2. And let me move this down a bit so we have space. Okay, so now that we have this set up, we just start with the leading terms here. So x to the 4th divided by x is x to the 3rd. And then you multiply. X to the 3rd times x is x to the 4. X to the 3rd times 2 is 2x to the 3rd. And then we subtract. But when you subtract, most common mistake in the world is people don't distribute. So we're actually going to subtract this, and we're about to subtract this. So these terms both cancel. So we get 0. And then the 4x just carries down. So I don't need to write 0. Just say like these like basically cancel, and we get 4x minus 10 just carries down. And now I start this process over. 4x divided by x is 4. I distribute, I get 4x, and 4 times 2 gives us 8. And we are subtracting. But I subtract both of these. These terms cancel, and then negative 10 minus 8 is negative 18. Okay, this is our remainder. So I have here, I would say plus remainder is negative 18. And we're over the original divisor is x plus 2. So you see it's in that form of quotient plus remainder over original divisor. All right, so this is what we need. But now the question is b of x a factor of a of x? So I'm going to say no. It's not, because in order for, think about it, for b of x to be a factor of a of x, b of x would have to divide a of x evenly with no remainder. Okay, so no remainder, if no remainder, that would tell us then, like, yes. That would mean yes, b of x is a factor. But that's not what happened here. We have a remainder of negative 18. Like, so I would say no. And I would say, like, why? A of x divided by b of x gave us a remainder of negative 18. So then, cool symbol coming up. Therefore, this means therefore, I promise. Therefore, b of x is not a factor of a of x. Okay, so that's what we need to know. Okay, so we are getting there. Calculator tricks. If you go back to the beginning, I did show some cool calculator magic at the beginning of the video for the multiple choice. Unless you were with us the whole time and like those weren't cool enough. So yeah. So let's see. Next is a simulation. And this is still on the Regents. Let me just get a sip of water, because I've been talking for almost 2 hours. But also, thank you, everyone, for being here. If you haven't subscribed, please, consider subscribing. It does help me grow the channel. But let's see. How do you change the sign for the long division problem? Oh, that's just like anytime I subtract, I distribute the negative. Okay, so like what was happening at this step? So like over here and this one is I subtracted this. So it's like the negative went through. And then the math that I'm doing is like 4x minus 10 and then like minus 4x minus 8. And like these cancel and then we get negative 18. So like that's really what's going on, is you're subtracting the negative. Okay, so cool. All right, let's see. Yeah, my goal, where are we now? Wow, today was a big day, passing 49,000 subscribers. I'm really set on getting 50,000 before the school year's out. That would be so cool. But if not, I mean, it's a marathon, not a sprint. But if you haven't subscribed, thank you. If you do consider subscribing and you do, joining the community. All right. So, question 35. This one, honestly, these I barely even think anymore. You have to think a little bit when you want to write your sentence explaining why. Explain your response. So, I guess I'll read it to put on a good, lead by example. So, a radio station claims to its advertisers that the mean number of minutes commuters listen to the station is 30. So this is their claim, like, hey, the mean number is 30. And the station conducted a survey of 500 of their listeners who commute, and the sample statistics are shown below. Okay, so that's their claim. It's pretty good, though. Like an average of 29.11 is like fairly close. If it's, and a standard deviation of this. So let's see. Moving on. Oh, wait, now the standard deviation was something else. I'm sorry. I'll just keep reading, though. So, yeah. So here, a simulation was run 1,000 times based upon the results of the survey, and the results of the simulation appear below. So here it is, a sample here of 1,000. And based on the simulation results, is the claim that commuters listen to the station on average 30 minutes plausible? And explain your response, including an interval containing the middle 95%. All right, so the moment you get to these questions, middle 95%, is just the mean plus or minus 2 standard deviations. So here I just take the mean is from the simulation is 29.101 plus or minus 2 times 0.934. So I just have the calculator do this for us. I'll show how I get it. But I just go 29.101. And I'll go minus first. So minus 2 standard deviations. So I just type that in. And then I go back up here. And here's a nice trick. You go up, you press enter, and it copies it. And then I just change that to plus. I just like overwrite it. And they told us to round. So this is where the Regents is so annoying. They tell you round to the nearest hundredth. So like you get 3 decimal places here, but they're like, sometimes they get you on rounding. Like I can't tell you like how many kids like thought they're getting 100 and then they get, you know, like a high 90, which is not terrible. Like it's still really good. But like, oh, you made a rounding mistake. And it's like, oh, that's annoying. But, you know, just make sure you're rounding to the place they tell you. So to the nearest hundredth. So here, that would be 27.23, comma, and then 30.97. Okay, so over here, 6 to the right is 9. So we would round up to 9.7. All right, and this would be our interval, which gets us partial credit right away. So now, is the claim plausible? Well, 30 is between these two numbers. So I would say yes. So yes, and I'll just write down what I have. So I'll say yes. The claim is plausible, but you have to use evidence from the interval. Okay, so is plausible. Try not to spell things wrong if the spelling is included in the question. But you still get full credit if you spell wrong and they could sound it out. So yes, the claim is plausible because 30 is in the middle 95% interval. Okay, so is in the middle 95% interval. I'm just using the exact language of the question. So including an interval containing the middle 95%. So I'm calling it the middle 95% interval. Okay, and that number is in between these two. That's how I know this is a good claim. All right. Oh, yeah, sure. We could say which multiple choice questions are the easiest. All right. You want me to rank them like right now? All right, here. Let's do that. Easy. So like, all right, if you just need to get 15, like don't get this wrong, please. This one, you just have to type in the calculator, so just don't make a typo. So 2, don't make a typo. 3, yeah, this, if you don't know, you're like kind of in trouble. This, if you look at that trick where you just type in the answer choices and store it, so rewatch 5. So let's see, that's like 4 questions right away that you could get right. This one, if you don't know that rule, like you're just kind of like done for. This 2, so I don't know, so far we're at 4. This one should be easy. Just graph it and see where the graph is going up. So 5. If you know definitions here, imaginary roots, like that, the graph is not going to hit the x-axis, then you might be okay. So I think this one is like very doable. So what am I at? 6. So so 6. And then let's see. This one I feel like is maybe like you could just kind of common sense it. It's very doable. This one is kind of rough, but if you know that calculator magic and you want to just take a leap of faith, then maybe that could be number 8 for you. This, if you don't know the rules, you're done. This, yeah, even if you have the calculator, this is hard. You have to know how to change the scale. So that one's kind of rough. This is, we could skip. This, just learn how to trace both sides. Or, I'm sorry, you go left side, right side, and then set the table to the independent from auto to ask, and then just type in the answer choices. So this is doable. This one's a little tricky. This one, pick an A value. Pick like A equals 3, and then plug in. And remember, inverse functions have symmetry over y equals x. So it would look like something like this, like symmetry. But I don't know, maybe that. Not polite if you don't know the formula. This one, You know what? You could graph like x squared plus 2x plus 1 times something else. Like let's say x plus something, like just x plus a number, and then get the right answer that way. So maybe this one. This one, yeah, wacky. Oh, this one, just graph all three. So this is like an easy one. This one too, I feel like is all calculator. This one too. So let's see. That's like 1, 2, 3, and then let's see, 4, 5, 6, 7. Oh, you said it. 8, 9, 10, 11. So 11 questions, and then you just got to know a little bit for the other part. So, yeah, I don't know. Just show up. Look, right now is like kind of like late to like learn everything you should know. But for future reference, like just learn as much as you can like throughout the year. So it's not, I wouldn't rely all on the calculator, but having calculator skills ups your chances. I'll just say that. All right. So this, solve algebraically. Now look, let's say you're like, oh no, I don't know algebra. You could, for half credit. So for half credit, you can just go 3 square root x minus 2x equals -5. Okay, I'm going to press zoom 6. And it looks like we have one solution. Let me go out to like x is 20. Yeah, it looks like we have one solution. Second trace 5. Because this looks like it's just going to decrease. 6.25. Okay, so they said, hey, algebraically, if you say, I don't want to do algebra because I don't know the algebra, I don't know how to solve this equation, but you go like this. You go, all right, you go like this, and then this, and say the point 6.25 comma -5, and then you just say like, all right, second trace 5, x equals 6.25. They'll give you half credit. Okay, this is half credit. Is like they said algebraically, but you do the math different, like use a graph, you get half. So like, oh, I need this many multiple choice to pass. If you don't know that algebra, do it in the calculator and get half. But if you want the 100, you want a high grade, then do what I'm about to do now. Okay, so if I want the full grade, I got to be able to do this. But if you combine the two, you at least know that this should be our only answer. Like we should have one answer. So we're probably gonna have to reject something, which like the calculator is nice to help you check. So for this, I'm gonna go plus 2x on both sides. And that's gonna give us, I'll write it over here, 3 square root x equals plus 2x and then -5. Once I get here, now I could square both sides. Now, some more math. A times b to the c is a to the b. I'm sorry, a times b to the c is a to the c, b to the c. So this is the same thing as I could say 3 squared is 9, and then square root x times square root x is x. Equals, don't say 4x squared plus 25, that would be a tragedy. What you're really doing is, you know what, maybe I'll write it out like this. I'll say 3 radical x equals 2x minus 5, 2x minus 5. This might make more sense. So then 3 times 3 is 9, root x times root x is x, equals, this is 4x squared. Don't forget the outer and inner. 2x times -5 is negative 10x minus 10x, and then plus 25. Okay, and then now we have 9x equals 4x squared minus 20x plus 25. Subtract 9x on both sides. Now from here you could use the quadratic formula, or we could use factoring by grouping. I like grouping more because I don't want to use the quadratic formula again. I use that in the multiple choice. So here we need two numbers that have a sum of this and a product equal to this. And if we think about, oh, I was just joking. The sum has to be, all right, AC method. Sorry, it's just a long day and my brain is starting to give out. So the AC method, A is equal to 4 and C is equal to 25. So A times C is 100. And the B value here is negative 29. So the two numbers that multiply to 100 and add to this are negative 25 and negative 4. So I could break this up here as, you know what, I'll say it like this. 4x squared, I'll say the minus 4x first. So I just broke this up into two pieces. So no like crazy, like nothing broken here. Like this is a valid move to break this up. But why'd I do that? Because now what I could do, and whoops, let me try to get that back. And I'll get rid of this, is now I could do factoring by grouping. So I take out a 4x, and I've got x minus 1. Take out a minus 25, I got x minus 1. And now this is 4x minus 25 times x minus 1. And now find the roots. So 4x minus 25 equals 0 when x equals 25 over 4, which is the same thing as 6.25. And then this one gives us a root. X minus 1 equals 0 is true when x equals 1. But if you don't check here, that would be like a real tragedy. You would lose a point for saying this is an answer. This one we have to reject. Okay, and why? If we plug it back in, so also over here, x equals 1, gives us 3 square root 1 minus 2 times 1 equals negative 5, which gives us 3 minus 2 equals negative 5, which is not true. 1 equals negative 5 is false, so not true. But the other one, 6.25, does work. Okay, if I plug in 3 times, square root of 6.25, maybe I'll write it like this, the 25 over 4, and then minus 2 times 25 over 4 equals negative 5. This one will work, okay? This is when x equals 25 over 4. Let me move some of this stuff over. Okay, I'll move this with this. So now I plug in, and this would make 3 times, this is, let me see here, all under 1 square root. So 3 times square root of 25 is 5, and then over 2. And then minus, this would give us, let's see, 2 over 4 reduces to a half, so I get minus 25 over 2 equals negative 5. And then this would be 15 over 2. So let's see, 15 over 2 minus 25 over 2 equals negative 5, which gives us negative 10 over 2 equals negative 5, which is true. Okay, so that's why this is our answer, but this is not. Okay. So let's see. All right. If we look, all right, part 4. So now this is where things get crazy. I graphed this one by hand, and it was like really just what's it called? Like exhausting. This is a log question. Someone was like, "Oh, hey, I hope you review logs," and I will. But I'll show you. Like, for me to graph this, it was pretty exhausting. Like it was especially the y-axis. You see, like I went like really heavy with this. What I did was I took the highest value here, and I wound up dividing by, let's see, I think I went up 20 spaces. So, yeah, I took 1.24 million and divided by 20 and got 68,000. So it was like really, really, really unpleasant to graph. But I mean, I'll show you how I start this, and then I'll use the model response to like guide the graph part, because I think people will fall asleep if I show all that. Just different strategies though that you could use. So here, Tony is evaluating his retirement savings. This is the last question too, by the way. He's evaluating his retirement savings. He has $318,000 in his account, which earns an interest rate of 7% compounded annually. And he wants to determine how much he'll have in the future. So we have to write the function here. So this was the one I wrote before a bunch, but here R is 7%, which is 7 over 100, which is 0.07. So we could say A of t is equal to 318,000 times 1.07 to the t power. Okay, so I'm just doing 1 plus 0.07. So just getting the function is like a first step here. But now watch, I'll show you like kind of like the challenges that you'll run into with this. Like this question I thought was kind of mean, but sometimes they make January like, you know, cruel. Like, I don't know. I mean, which I think like if students fail it and they got to like, you know, they want to retake it, like why up the difficult? I mean, but I don't know. I don't write the Regents. It's not my, you know, call to make. But I go to graph this. I'm like, oh, I can't see anything. Well, for one, if I go from 0 to 20, look how we're going up to, let's see, at 20, we're at like 1.2 something million. So I think I said like, all right, how about I go up to 1,240,000? So 0 to 20, because we're going from 0 to 20. And then for the Y maximum, 1,240,000. And let me see if I get enough zeros, and I do. And like, see, like now we could see this, but I can't just like draw a curve and hope for the best. So here we get these values, but like these values are very unpleasant. Okay, so what I did was I said, all right, if I go up to 1,240,000 and it's 20 spaces, I divided 1,240,000 by 20. And I got 62,000. And then I basically graphed the line 60. Let me see. I had, what did I say? 60. Oh, yeah, 62,000 here. I'm sorry, I said 60. I think I said 68 before. But then I counted by this on my graph. And I graphed it. Okay, so it's like, it was like just very tedious. I don't know. Sometimes, like, I think if this were the question, I would get exhausted. But I'll show you like the model response, like how they, you know, put everything down. So what they did was they counted by thousands. They didn't write out like the 100,000. They were like, hey, this is the amount in thousands. And this is like, yeah, what the student put. Okay, so let's see. So this is like the model response. So if you look here, like at 5, like if we put this side by side with the calculator, so I'll go back to the table. See how like at 5, we're at 446,000. And then that's like a little bit under 450. So they counted by like 150,000, 300,000, 450,000, 600,000. And then they counted by 5s on the t-axis. So then like see at 10, we're at 625,000 and change, which is a little more than 600,000. So that makes it like way more reasonable than like finding the scale the way I did. Like I immediately like their way more, but I wanted to do it myself just to see like get a sense for what kind of struggles we could run into. So if you're dealing with giant numbers, like make the y-axis count by like in thousands. So it's like 750, but 750,000. Okay, and then by the end at 20, we are. I'll look at the table here. We're hitting almost 1.24 million. So see here, that would be like somewhere in this range here that they graph. All right, so this would be for the graphing portion. But then they say, Tony's goal is to save $1 million. Determine algebraically to the nearest year how long it's going to take him to reach that goal. So we would take our function here, a of t. I'll just copy this. So let me just see. Can I? Yep, I can copy that. And we want to see how long it's going to take to hit 1 million. Oh, whoops, I copied the wrong one. That's a fail. I'll just rewrite it. I don't know why I'm... so A of t was 318,000. And then times 1.07 to the t power. Okay, and we want to know when does the amount hit 1 million. So 1 million is 1 with 6 zeros. And we set it equal to this. So if we're doing this with logs, because we have to do this algebraically, we divide both sides by 318,000. Okay, this I would type in the calculator and see like what's the simplified fraction, because that's going to be annoying to write. So I would do, okay, 1 million is 1 with 6 zeros divided by 318,000. And then I would press math, enter, enter. So 500 over 159. Okay, so I could simplify that to 500 over 159. That's just an easier amount of numbers to write. And then equals this. But now, there's a few different ways we could do this. But like, let's say we don't know to do like log base 1.07. I could do like regular log of both sides. So log of this side and then log of this side. And now here, I'm using that exponent property from before. T could go in front. So now I have log of this equals T times log of 1.07. And then just divide both sides by log of 1.07. So divide. And then just don't make a typo in the calculator. So T to the nearest year. So T equals, and now I'll just type this in. Let's see. So we've got log of 500 over 159. And then log of 1.07. Okay, is like roughly 17 years. Okay, so it's going to take Tony 17 years to hit 1 million. So 17 would be our answer, but they say explain how the graph confirms your answer. So if we look here, see how like 1 million is equal to 1,000 thousands. Okay, 1,000 times 1,000 is 1 million. So if you want to be a millionaire, you got to make $1,000 1,000 times. Okay, that's a lot. Okay, so here 17. See, like at around 17 is where the graph of A of t intersects y equals 1,000. Okay, so explain how the graph. Well, we could say A of t intersects y equals 1,000 near t equals 17. All right, so that would be it. That would be, and it's, but once again, this only works because we define this like in thousands. Okay, so like 1,000 thousands would be 1 million, but that would be enough here to get the credit. All right. Do you know if natural log stuff will be included? All right. Well, so natural log, what makes natural log special? So I'll just do, let me see what time it is. I could do like a little Q&A. But natural log is really just like y equals natural log x. Make that neater. Is really just like y equals log base e of x. So you really just use that if you had like, let's say like, oh, e to the x plus 5 equals 7. Like, when is that true? Like, then I might say, all right, natural log of e to the x plus 5 equals natural log of 7. And then natural log and e cancel out, and you get x plus 5 equals natural log 7, and then minus 5 on both sides. Don't say natural log 2. That would be tragic. And that would be negative 5 plus a natural log 7. Okay? Oh, directrix is not on the Regents anymore, Nicole. They took that out. So, yay. Directrix is out, and 3 variable systems are out. Yeah. Let's see. Yeah, I mean, that's like basically what I have. I'm happy to see though. Wow, almost over 4,000 people stopped by. Thank you all so much for supporting the channel here. I can't express it enough. Just thank you for coming to the live stream and going through a Regents with me. I still do get like people are nervous before their test, but I still get nervous like when I have to go on a little bit because I do want to make this useful for people and helpful. I want to see you all do well tomorrow. I really wish you all the best. And but I know everyone's going to have a different experience tomorrow, okay? And no matter how you do, just know I'm proud that you put in the effort and you're here now, trying your best to up your score. Graph tangent. Yes, I did promise that. I don't want to break my promise. So graphing tangent. Although if you click on the description of this video, I did include my sample question video. and graphing tangent is like one of them. So just in general, like y equals tangent x. Now remember in you learn tangent is equal to sine over cosine. So what I think about is the graph of cosine. So cosine of x looks like this, right? It just goes like that. It has roots at pi over 2 and at negative pi over 2. Okay, so this would be like the graph of cosine. So that's why the graph of tangent has vertical asymptotes at pi over 2 and negative pi over 2. So just remember this phrase. The roots of cosine x are the vertical asymptotes of tangent. Okay, so just remember that. The roots of cosine tell you where the vertical asymptotes of tangent are. So that's why, like here, all right, the graph of tangent looks something like this. So it goes down like this. Okay, so that's tangent x for you. If you go to a calculator, you go y equals tangent x. Make sure you're in radians. You press graph, zoom 6. See, it just gives you all this. If I restrict my domain, so window, I go from negative pi over 2 to pi over 2. This will give me just one of the tangent pieces. Okay, so I go between the asymptotes, and that'll give me just one piece. See, that's one piece. All right, the values, if I was making a table, I would go half from 0 to pi over 2 is pi over 4. So I would go pi over 4 and negative pi over 4. And if you do that, that's going to bring you up to 1, and it's going to bring you down to negative 1. Okay, so these are the 3 points I would include, like negative 1 for the y value, 0 and 1. And it's like the halfway point to the asymptote. Okay, so if I even went to the calculator and I press second trace value and I plug in pi over 4, that's going to give me y equals 1. Okay, and then second trace value, negative pi over 4 is going to give me y equals negative 1. Okay, so cool. 37b. What was 37b? Oh, this one. Okay, so for 37b, I set our function equal to 1,000,000. But then first divide by 318,000. And that gets you to, I'll just show without, gets you to this step. So it gets you to here. Okay, but then just tell yourself this. Logs are the opposite or inverse opposite of exponent or exponential. So logs are the opposite of exponential functions. So when my variable is an exponent, see, like this is an exponent, I'm like, ooh, do the log of both sides. So I take the log of both sides. I could do regular log. I could do natural log of both sides. Like pick your favorite log, and you could do that to both sides. Okay, but I chose like log base 10. If there's no number written at the base, it's log base 10. Okay, so I have log base 10 of this. But then the exponent property is I could bring the power t in front. And then once I have t times log of this, I just divide by log of 1.07 on both sides. And then I get my answer. Okay. Yeah, inverse functions is like when you have, I don't know, like let's say f of x equals like cube root of x plus 1. Like I just imagine this as y equals cube root of x plus 1. And then you switch x and y. So you say x equals cube root of y plus 1. And then you do the algebra to solve for y. So for something like that, you just go, all right, opposite of cube root is power 3. So I raise both sides to the third. I get x to the third equals y plus 1. And then I subtract 1. And now it tells me x to the third minus 1 is equal to y, which I could then say my inverse function is x to the third minus 1. Yeah, period. Oh, so trig stuff. So period is 2 pi over b. Frequency is the reciprocal, so that would be b over 2 pi. This is new for 2026. All right, so trig stuff. I'll get this out of here. All right, I should just press the cut button, but now I'm committed. and nothing worked. So good. We'll never get those seconds back. All right. So let's see. So yeah, last minute Q&A, and then I'm going to sign out. So this, like, yeah, y equals a sine or cosine, but if I have this, okay. I think now they're doing horizontal shifts, though. The last one I remember, at least on the, so if I write this plus d, like this helps you find the amplitude. I'm not going to say it is the amplitude. It helps find amplitude. Okay, the absolute value of a tells you the amplitude. Okay, so how about I say that instead? Okay, so absolute value of a is the amplitude. B helps you find frequency and period. This is the horizontal shift. And this one is the midline. Okay, so like if we just explore that one a little bit, I'll help you, well, hopefully help you understand it. Like if I just pick values out here, like let's say I start with like 2 sine of 3x plus 4. And I go like, all right, from 0 to, I didn't do a shift. So let's say I go 0 to 2 pi. And then from 0 to 10. So you see I get this. So 2 sine. So that means like my absolute value of 2 is 2. My amplitude is 2. My midline is 4. So if I were to graph the line y equals 4, you could see like, oh, all right, that's my midline. So let me actually just borrow this so you could like, we could see like which function I'm referring to. Oh, that blinked at the worst time. Oh, now it's stuck. Yeah, this is just, now this is a, yeah, pain. Let's see. Oh, maybe if I just go here so the blink doesn't become like a video game trying to time it. Okay. All right, let's see. So this one, yeah, if I do 2 sine 3x plus 4, something like this. I look at the graph. See the line y equals 4 is our midline. The amplitude is 2. That's the distance from the midline up to the max or midline down to the minimum. And then the coefficient 3 tells us that we're going to complete 3 cycles every 2 pi. So I went from 0 to 2 pi, and you see how you have 1, 2, 3 full cycles of the graph. Okay, so it's 3 full cycles every 2 pi along the x. Okay, the period would be 2 pi over 3, and that would be how much time it takes to complete 1 cycle. So if I change my x maximum to 2 pi over 3, that should give us 1 cycle. And it does. See, 1 full cycle. Like this. If I throw in a horizontal shift, so this is where things get a little wacky. Let's say I do a horizontal shift of, let's say pi over 2. So x minus pi over 2. And then I write r plus 4 on the outside. So I do this. And what that does is it tells us, like, let me go back to 0 to 2 pi again. It may not seem like it changed a lot, but now if I do second trace value and I go to pi over 2, it basically just slid the whole graph to the right, pi over 2. So now my cycles start this way. That if I, like, let's say I started, I go 2 pi, but now plus an extra pi over 2. Like this. So now I'm going out more. You could see when I go to pi over 2, so back to pi over 2 on the x, that my graph is starting here. Like this is where, like, almost where I'm beginning. And then it's like 1 cycle, 2 cycle, and then the third cycle ends at 2 pi plus pi over 2. So let's see, 2 pi plus pi over 2. So it just slides things over a bit. Okay. Alrighty. All right, people, but this is all I've got for today. I will tell people you should probably get some rest, stay charged. There is like a law of diminishing returns. Like you stay up really late studying. Some people are like, oh, I'm going to stay up till like the test. I don't recommend it because like law of diminishing returns is like study. And then there's like the law of diminishing returns. This is where it's like starts like you. This is where you start learning less. And then you're just like, oh, I'm going to learn, like, I'm going to study for, like, this is like, here, like, go to sleep. But then the kids who were like, oh, no, I'm going to drink, like, a Celsius and just stay up, they think they're learning so much. So this is like, the Celsius kid. So the Celsius kid is like, oh, I'm going to stay up all night. And they, like, learn, like, half a new thing. And then, like, 5 minutes into the test, they just fall asleep and fail. So go to sleep. But thank you for stopping by, and I wish you all good luck tomorrow, okay? Take care. And subscribe if you haven't subscribed, and this was helpful. Thank you.